All right, so this is just a recap from the notes in class. Percentiles, there are 100 percentiles, so that we know that our P% of our data, like, if we're in the P percentile, right, or the nth percentile, is going to be less than or equal to P. And then if we want to find out where we are, we take 100 minus P, and the data is going to be greater than or less than. But let's look at an example. So it says you took the English achievement test to obtain college credit in freshman English by examination. If your score is at the 89th percentile, what percentage of scores are at or below yours? So this is what we want to think of when we're talking about percentiles. So we are at the 89th percentile. All right, so that means that you scored higher than 89% of your peers. Okay, what percentage of scores are higher than yours? All right, so this we just take 100, subtract the percentile we're at, and that gets us 11. So that means 11% are higher. If the score is ranked from 1 to 100 and your raw score is 95, does this necessarily mean that your score is at the 95th percentile? So no, it really depends on what everyone else got. It doesn't necessarily depend on your score out of 100 if the tests are out of 100, okay? It could be possible that you got 95, but most of the people got 98. So would you be at the 95th percentile? No. So I guess you have to take the other scores into account. All right. So next what we're going to look at is quartiles and interquartile range. So quartiles essentially divide our data into fourths. All right, or 25%. Our first quartile is the 25th percentile. Our second is the 50th. And also know that it represents the median of the data, right? Because the median's the middle. And lastly, our third quartile is in the 75th percentile. Okay, so here's our quartile 1, our quartile 2, right? And then our quartile 3. The interquartile range, or the IQR, is the difference between quartile 3 and quartile 1. The IQR, you can find the range of your values in the middle 50% of your data set. We're just looking at the middle range. Okay, and it's also known as a measure of spread about the median in your data. So let's look at 2 examples for that. So for this first data set, our median's in 6 and our IQR's at 4. Our second data set, we have a median at 6, but our IQR's at 10. All right, so for this one right here, our first data set, we have a smaller spread. Notice how this is 4. So we would talk about it by saying data set 1 has a much more narrow spread. All right. Okay. So essentially, how would we compute quartiles? First, we would order the data from smallest to largest, like we're about to find the median. And then we find the median. And then we know that our median is our second quartile. Our first quartile is then the median of the lower half of the data. All right. And then that's going to be below the second quartile, all right, and not including quartile 2, and I'll show you how to do that. And then quartile 3 is just essentially going to be the opposite. So let's look at 2 examples, all right? So we're going to find the quartiles and then find the IQR. So first I'm going to list my data from least to greatest. So 10, 11, 14, 15, 16, 19, 20, 21, and 21. All right, so if I count both sides, I find that 16 is in my middle, so it's my median. Okay, so then I have my lower half of the data and my upper half of the data. All right, to find quartile 1, I look at the median. Now see how I have 2 numbers in the median? So I got to find the mean of those 2 numbers. 16 was in the middle. There wasn't anything on either side of it. Or I mean, this is an odd set of data, so there weren't 2 in the middle. So I'm going to take 11 plus 14, divide by 2, and I'm going to get 12.25. Oh, sorry, 12.5. So quartile 1 is 12.5. And I'm going to do the same thing here. 20 and 21 are in the middle, so I find the average of those 2. So 20 plus 21 divided by 2, and that gets me 20.5. So my quartile 3 is 20.5. All right, my quartile 2, which is my median, it's not really ever really referred to quartile 2, is 16. Okay, and then lastly, to find my IQR, I have, I subtract my quartile 3 and my quartile 1. So 20.5 minus 12.5, and that gets me an IQR of 8. So why don't you take a second, find the quartiles for example 3 and the IQR. Pause this video. All right. So you should have gotten for quartile 1, 38, median, 65, quartile 3, 90. And then when you found your IQR, you should have gotten 52. All right, moving on. So next we're going to be talking about box and whisker plots. So basically with box and whisker plots, what they do is they give us this very useful thing called a 5-number summary. Oops, summary's already on there. So our 5-number summary, and it basically gives a summary of our data and its spread, okay? And a box and whisker plot is a really great way to display a 5-number summary, all right? And so on your box and whisker plot, you're going to have your lowest value. You're going to have your quartile 1. You're going to have your median. You're going to have your quartile 3. And then you're going to have your highest value. All right. Sometimes outliers will be represented by little dots. And then we can also display a box and whisker plot vertically. All right, same thing. Here's your least value, your quartile 1, your median, quartile 3, your high value, and then your outliers. So outliers occur when any value is beyond 1.5 times the IQR, all right? So that's how you would figure out if a number would be an outlier for your data. All right, to make a box and whisker plot, first you're gonna draw a horizontal or vertical scale. Then you're going to draw a box from your quartile 1 to your quartile 3. Then you're going to include a solid line through the box at the median level. And then you want to double check for outliers and draw them as individual points, okay? So let's do an example here. So for number 4, we're going to find the 5-number summary, and then we're going to make a box and whisker plot. So for our 5-number summary, I'm going to kind of do this a little quickly. We're going to go straight ahead and I'm going to give it to you. So our minimum value is 19. Our quartile 1 is 38. Our quartile 2, or our median, is 65. Our quartile 3 is 90. And our max is 95. So we know that our IQR is 52. And then if we want to find out what our outliers could be, remember we take our least value, we take our quartile 1 and our quartile 3 and we either add 1.5 times our IQR to find out if we have outliers. So again, my quartile 1, which is 38, I'm going to subtract 1.5 times my IQR, and that gets me negative 40. And then I'm going to take my quartile 3. I'm going to subtract 1.5 times 52, which is my IQR, and I get 168. So notice how our min and our max do not surpass these numbers. So that means we have no outliers. All right. So now what we're going to do is we are going to make our box and whisker plot. So I think I'm going to count by 5s, and I'm going to start at 15. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95. All right. And you want to have it somewhere, within your min and your max. So I'm going to plot all my data. So I have my min. I'm going to do my quartile 1, which is at 38. So 15, 20, 25, 30, 35, 40. So it would be about here. For my quartile 1, this is my min. And then my median is at 65. So 40, 45, 50, 55, 60, 65. So this is where my median would be. 70, 75, 80, 85, 90, 95. So, and then 90 is my quartile 3. And then 95 is my max. Okay? So now that I have all these plotted, what I'm going to do is I'm going to draw my box and whiskers. So you draw your box around quartile 1 and quartile 3. You draw a line through the medium, and then your whiskers go out to your min and your max. Take a second to try example 6 on your own and pause the video. All right, so for example 6, I'm going to work this entire one out. Make sure you did it the same way as well. So I have 1, 2, I'm going to list my data in order. 1, 2, 3, 3. Oops, there's an extra 3 in here. 1, 2, 3, 3. Let's see. 5, 6, 7, 7, 10, and 20. And then 3 and, oops. So my medium is going to be right between 5 and 6, which is 5.5. My quartile 1 is at 3. And then my quartile 3 is at 7. All right, so then I'm going to list my 5-number summary. So my minimum or my least value is 1. My quartile 1 is 3. My median is 5.5. My quartile 3 is 7. And my max is 20. So let's find out if there are any outliers. So I take my IQR. So 7 minus 3 gets me 4. So now I'm going to add 1.5 times 4 and subtract 1.5 times 4 to quartile 1 and 3 and see if there are any outliers. So quartile 1, I'm going to go 3 minus 1.5 times 4, and that gets me -3. Now I'm going to do this with 7. 7 plus 1.5 times 4 gets me 13. Okay, so that means that any number that's below -3 or above 13 in my data set is an outlier. So I don't have anything lower than -3, so that one's fine. However, for this one, notice how I have 20. 20 is greater than 13. So therefore, I do have an outlier, and so 20 is the outlier. Okay, now let's make our box and whisker plot. So our data goes from 0 to 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so my minimum is 1. My quartile 1 is at 3. My median is 5.5. My quartile 3 is at 7. And then my max is at 10 now because 20 is an outlier. Draw my box and my whiskers. All right. So next we have 3 classes A, B, and C took the same test. So another thing that we can do with box and whisker plots is to show off differences between groups. So here we know that all 3 classes had the same high and low score. And how do we know that? Because look, they're all the same here with the low, and they're all lined up with the high. All right. We also know that scores in class C, all right, notice where they are. They're generally better than these scores, right? They're lower. Scores in class C were better. And we know that class A and B, their medians were pretty close. However, C was still higher. Alrighty. All right, next example. So looking at this data, what is the range of the sugar content of these cereals? So, well, we know that our high, let's see, where's our high? Oh, sugar content, sorry. We're looking at sugar. I was looking at the cereal. So sugar content is about a high of 60 and then a low of 0. Okay, so if we're looking at the range, we just subtract. $60 minus 0 is 60, so our range is 60. All right. now if we're going to describe the shapes of our distributions, our histogram, all right, so notice how it has 1, 2 humps. So we're going to call that bimodal. All right. Our adult with box and whisker plot, notice how if this was to be standing upright, it would probably look like this. And so because the tail is pulling to the right, you'd say it was skewed right. For this one here with children, it kind of goes in the middle. All right. So I'd say it's symmetrical. And then it says, are all children's cereal higher in sugar than adult cereal? Well, if this is our children's cereal, notice how they're all higher in sugar. So I'd say yes. And then which group varies more in sugar content? All right. So notice how a lot of our data here for the adults is pretty far from the median, whereas it's kind of closer to the center for the children's. So I'd say adults varies more. And you really want to look at your data and see how close it is to the median. All right. And then one more example. Which of the following box and whisker plots suggest a symmetrical data distribution? Take a guess. Which one do you think? If you answered D, you are correct. And then last but not least, take a second to read this comic. It might bring a smile to your face.